Scalar multiplication. Okay. So suppose you have a vector A 3 comma 2, okay, and you're multiplying it with any scalar. So scalar we usually denote by letter C, okay. So your C is any constant, like it can be literally any number, 1, 2, 3, 4, 5, whatever, okay. Then all the components will also get multiplied by C. So this will be 3C, comma 2C. For example, let's take C as 5. Okay, so 5
Mm-hmm.
times A will be 5 times 3, 15, and 2 times 5, 10. That's it. Okay,
Okay.
so you can imagine that the size of the resultant vector. So if now this is my resultant vector,
Mm-hmm.
its magnitude will be 5 times the original vector, you
Mm-hmm.
know. Exactly. Okay, so first is 2v. Okay, so this is very easy. First, just multiply 2 with v. So this will be 2 times your v vector. Okay, so this will become 4 comma negative 2. Okay, now
Mm-hmm.
you just have to show it graphically. So when you show it graphically, you have to show the original vector as well as the resultant vector. Okay, Shruti, whenever we do any operation, the final answer that we get, that is called the resultant vector.
Okay.
Okay, so this is called resultant vector.
Mm-hmm.
Well, whether you're adding, subtracting, multiplying, the final vector is called resultant vector. Now, whenever you have to sketch the graph, you will show the original vector and also the resultant vector. So first you can show the original vector, which is 2 comma negative 1. So 1, 2, and this is negative 1. This is 2, this is negative 1. So your vector v is this, okay? And then 2v is 4 comma negative 2. So this is 4 and this is negative 2. Probably try to use another color if you can to show the, like two, whenever you have to show any two different vectors, so it's better to use different colors. See, now it will have the same angle, it's just that its magnitude will be different.
Mm-hmm.
So this one is 2v. Okay. Then part B says v minus 2
Oh.
w. Next part is, in the next part, they have actually combined two operations.
Mm-hmm.
There is v minus 2w. Here they have combined two operations. First, they have multiplied vector w by 2. So this here they have done scalar multiplication.
Mm-hmm.
And after that, you have to add, like, sorry, you have to subtract negative 2w from v. So here you'll have to do actually three operations. First, you multiply w by 2, then you find out the opposite vector of that, and then you add it to v. Okay, so w was 0 comma negative 3. First, we are going to find out what will be 2w. So can you tell me what will be 2w?
0 and negative 6.
Yeah. Now we will find out opposite of 2w, negative of 2w. Okay, what will be that?
Um, that would be 0 and then positive 6.
Exactly. And now we will find out what will be v plus negative of 2w. Okay. Okay, so v was 2 comma negative 1. Okay, so that means we have to do 2 comma negative 1 plus 0 comma 6. Is that okay? Okay, now just add the respective components.
2 and 5. Sorry, this is 2 and 5, yeah.
Yeah, 2 and 5. Okay, so that's the final answer. Now we also have to sketch the graph for it. Okay, so first let's draw vector v. Again, remember,
Mm-hmm.
whenever you have a problem of subtraction, instead of drawing this vector, see, we will not draw this vector. We will draw the opposite of this vector, okay?
Mm-hmm.
So first we will draw vector v, and whichever vector is written first, that is called the first vector, and the vector which is after the subtraction sign, that will be your second vector. So first we will draw first vector, vector v. Okay, so 2 comma negative 1. So this is 2 and this is negative 1. So this is vector v.
Mm-hmm.
Draw the tip and tail as well. And then you just have to draw the tip. Don't in tail you don't have to do anything. Just write the word tip here so that you don't get confused. Then draw the second vector. Now second vector is negative 2w. So we'll draw this vector, negative of 2w. Okay, so how much is this? 0 comma 6. 0 comma 6. So 1, 2, 3, 4, 5, 6. Okay, Shruti. So 0 comma 6 is, I should use blue color. It will be a vertical vector. This is vector negative 2w. This is negative 2w and this one is v. And now what was the next step? Hello.
Oh, sorry. Like we have to keep it on top of the tip. Like the end should touch the tip.
Yes. So I will pick up the second vector and put it on the top of the tip like this. Okay. And then we will connect the tail of the first vector and tip of the second vector. Oops.
Mm-hmm.
This is the final resultant vector. So this is this white one. This is v minus 2w. And you can verify it by looking at the coordinates of this white vector. See, this is 2 comma how much? 2, 3, 4, 5. This is 2 comma 5. And this is exactly what we got when we did it algebraically. You should always verify your work, okay? How will you verify? For the resultant vector, write the coordinates. So this is the resultant vector, white colored one. So its coordinates, you can see it is 2 comma 5, and then also verify it algebraically. Even though in the test they are not asking you to show the manual work, even then in your rough work just quickly add them manually and see if you're getting the same components.